Hi everyone, I welcome you all to my YouTube channel. The topic for today's session is liquid pressure. The learning objectives for today's session are activities related to liquid pressure, characteristics of liquid pressure, factors affecting liquid pressure, Pascal's law with activity, manometer, and finally consequences of liquid pressure. So let's start with the activities related to liquid pressure. As you can see in the first figure, we have taken a glass tube and we have tied a balloon at its lower end. Hold it vertically as shown in the figure A. Pour some water in the tube. You will notice that the balloon bulges out due to the pressure of water column. Next we have another activity. In this activity, we have taken a glass tube which is open at both ends. Hold it vertically. Tie a balloon at its lower end. Pour some water in the tube. You will notice that the balloon bulges out as shown in figure A. Add some more water. You will find that the balloon bulges more as shown in the figure B. This shows that greater the height of the water column in the tube above the balloon, greater is the pressure exerted by it on the balloon. This shows that liquid pressure increases with the height of the liquid column. Let's see one more activity. In this activity, we have taken a glass tube which is closed at one end and having an opening in its side near the bottom. Now we will tie a balloon at the side opening of the tube and hold the tube vertically as shown in figure A. Next we will pour some water in the tube as it is visible in figure B. Now what you will notice? You will notice that balloon bulges due to the pressure of water on the sides of the wall. The pressure exerted by liquid on the sides of the wall or its vessel is called lateral pressure. Greater the height of the liquid column, greater will be the lateral pressure exerted by it. Now let's discuss the characteristics of liquid pressure. The first one is liquid exerts pressure on the walls of the container. You can see we have taken a glass container in which we have filled some liquid, and the arrows show that the liquid pressure is exerted on the walls at the bottom in every direction. The liquid pressure is exerted. Next we have the second characteristic feature which tells us liquid pressure is directly proportional to the density of the liquid. For this we will do one activity. Yes, we will take two identical glass tubes and mark them as A and B, which are open at both ends. Now we will hold them vertically and tie a balloon at the lower end of each tube. Next, we will pour some water in the tube A and some mustard oil in tube B such that its height in the tube B is same as the height of water in the tube A as shown in the figure. You will notice that the balloon attached with the tube B bulges more than that attached with the tube A. This shows that the same height of the mustard oil exerts more pressure than the water. Since the density of mustard oil is more than that of water, therefore the conclusion drawn is liquid pressure increases with the increase in the density of the liquid. The third characteristic feature is liquid pressure increases with depth. For this, we will do one more activity to understand this feature. We will take an empty tin cylinder, make two holes in it, and mark them as A and B near the top and near the bottom. Now we will close the holes A and B with an adhesive tape. Now, next, we will place the cylinder on a block kept on a table. Fill the cylinder with water. Remove the adhesive tape from the holes. What you will notice? You will notice that the water coming out from the upper hole A falls near the cylinder, and the water coming out from the lower hole B falls farther from the cylinder. This clearly shows that liquid pressure at a point increases with the height of the liquid column above it. So, the characteristic feature is liquid pressure increases with depth. As you can see, the depth of hole B is more as compared to A. Therefore, liquid pressure is more at B as compared to A. The fourth characteristic feature is liquid pressure is exerted equally in all directions at all points lying at a given depth inside the liquid. For this, we will do an activity. Now, we will take a balloon, fill it with water, tie its mouth, and make some holes in it by inserting a pin at several places in all the directions, but at a given depth. Now what we will do? We will exert pressure, or by applying an external pressure on any point of the liquid, what we will notice that the pressure is transmitted equally in all direction. It will be visible by the flow of the water through each hole coming out with the same pressure. The pressure of the water through each hole is equal, undiminished in all directions. The last characteristic feature is liquid seeks their own level regardless of the shape and size of the vessel. Here we have a figure. You can see we have different types of vessels interconnected with each other. We have A, B, C, D, E, all have different shape and size, but all are interconnected. But what we notice? We notice that the height of the level of liquid in tubes of different cross section always remains same, although volume of water is different in different tubes, as is visible in the figure. This is called hydrostatic paradox. So now let's conclude, or let's summarize all the characteristics of liquid pressure once again. The first is liquid exerts pressure on the wall of the container. The second is liquid pressure is directly proportional to the density of the liquid. Third, liquid pressure increases with depth. The fourth is liquid pressure is exerted equally in all directions at all points lying at a given depth inside the liquid. And the fifth one and the last one is liquids seek their own level regardless of the shape and size of the vessel. The next topic is the factors affecting the liquid pressure. How many factors are there? There are two factors which affect the liquid pressure. The first one is the height of the liquid column. Liquid pressure increases with the height of the liquid column above the point. And next is the density of the liquid. Liquid pressure increases with the increase in the density of the liquid column. So these are the two factors which affect the liquid pressure. The more is the height, or you can even call it as the depth. The more is the height of the liquid column, the more is the pressure, and more is the density of the liquid, more will be the liquid pressure. Next, we have Pascal's law. The word Pascal has come from the name of a French physicist, Blaise Pascal, who has contributed a lot in the study of liquid pressure. So, as a gesture of respect, the law given by him is named as Pascal's law. According to this law, pressure exerted at any part of a confined liquid or fluid is transmitted equally and undiminished in all directions. Now, we will do an activity to understand, or we will do this activity to verify Pascal's law. So, what we need is a long necked glass flask fitted with an airtight piston and having a glass bulb with a number of holes in different directions known as Pascal's apparatus, and a beaker with water. Now the procedure is, you will push the piston to remove all the air from the flask, and then you will immerse the flask in a beaker full of water and pull the piston up to fill water in the flask as we do in a syringe to fill the medicine. Remove it from the water and push the piston and observe what happens. When we are pushing the piston, we are actually exerting force per unit area. That is, we are exerting a pressure on the piston. And what we will observe? We will observe that water flows out of all the holes uniformly and with the same force. And hereby it verifies Pascal's law, which states that pressure exerted at any part of a confined liquid, here the liquid is confined in the round bottomed flask, and the pressure is exerted with the help of a piston at one end, at one part of this confined liquid. And what we notice, that the water gushing out shows us that the pressure is transmitted equally and undiminished in all directions. Next, we have a manometer. What exactly is a manometer? A manometer is a device used to measure the pressure exerted by a liquid. So here we have the figure. It is constructed by fixing a U-shaped glass tube open at both ends to a wooden board with a scale as shown in the figure. The scale should be able to measure the readings marked on both the sides of the glass tube. One end of the glass tube marked as arm A is then connected to a container having a liquid whose pressure is to be measured, whereas the other end, arm B, is kept open. The pressure of the liquid is determined from the difference in the readings of the two scales. Now we are going to discuss the consequences of liquid pressure. The first figure, as you can see, is of a dam, and the second figure is showing us that the water pressure or the liquid pressure is increasing with the depth. This is one of the characteristic features of liquid pressure, that liquid pressure increases with depth. So you can see the construction of the dam. You can see that the base of the dam is broader as compared to the top. So, as you can see in a dam, the walls is much thicker at the bottom than it is at the top. What is the logic behind this? There is a simple logic that the liquid pressure increases with the depth. So as to combat this enormous liquid pressure, the bottom is made much thicker as compared to the top. The next figure is, as you can see, we can see deep sea divers wearing a special design suits. Again, why are they wearing this type of special design suits? This is again, the reason is same, to protect themselves from being crushed by the high enormous liquid pressure in deep oceans. Again, the same logic. Liquid pressure increases with depth. So, when the sea divers go deep into the ocean, there the liquid pressure is more. The pressure is so much that it can crush their body. So, as to combat this liquid pressure, they have to wear special designed suits. And yes, this we can see in our locality. The water supply tank, yes, they are placed at a higher point as compared to the heights of the building in the area. Again, the same logic that liquid pressure increases with height. So, if the water is placed at a greater height, the pressure with which it will be supplied to our home will be great, will be higher, will be more. So, with this, we come to the end of our session. Thank you, my dear children, for viewing my YouTube channel. God bless you. Don't forget to like, share, and subscribe my channel. Bye for now. See you soon with yet another video on atmospheric pressure.